Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to be discussing voltage in electric circuits, and we're going to be using the terminology that voltage is energy applied to the electric circuit. So we're talking about voltage, current and resistance as three kind of properties of an electric circuit, and trying to think about the role that energy has in each one of them. So what I have here, I've got a simple diagram of a AA battery over here. Okay, so one thing that you'd be hopefully aware of with a AA battery is that opposite ends of the battery are, one end is positive and the other end is negative, or that's the kind of the label that we use. And so when part of what we're going to be looking at is saying, right, well, what role does the positive and negative aspects of a cell or a source of energy in a circuit have? Okay, and so what we're going to do is I'm just going to kind of clear that away for the moment, just so you can kind of see that I'm going to kind of zoom in a little bit for this bit down here. And then what we have here is a simplified diagram representing an electrical, like a metal wire. Okay, the sort of one that we would use to in an electric circuit to connect up components. Okay, so each of these little red circles here represents a negative electron. Okay, so negative electrons. Okay, so that they've got a negative charge and they're able to flow in this wire, but at the moment they're kind of staying still. They're in a particular spot. And so in an electric circuit, so that there is some form of a push. Okay, so that this is a type of force. Something in that circuit that provides a push that then causes those electrons to actually be pushed or moved around the electric circuit. And so the pushing force is this thing that applies what we call voltage. So voltage is this idea of the pushing force in an electric circuit. Okay, and so what we have is that a source of voltage that like a battery or a power pack or something like that, there's a section that has a positive charge and a section that has a negative charge. Okay, and so what we can then say is, all right, so this bit has a negative charge. Each of these electrons is negatively charged. One of the things that we know is that opposites attract when we're thinking about charge, and like charges repel. So I realize that's only just kind of pushing off the bottom there. Okay, but so this idea that opposites attract and then like charges repel, okay, which is the one that we're particularly interested in here. This idea that these two negative charges that are next to each other are going to be pushing away from each other. And so what happens then is that this negative charge over here isn't able to move. It is permanently negatively charged. But this negative charge, however, is able to move. And so what it does is that it moves, and it will move away from this negative charge here. And what does it do? But it collides with, or kind of comes close to, this one over here. And then what happens if I might take a couple of these out and spread out the space so you can see it a little bit better. Okay, so this one over here, then it pushes closer to this one, which then pushes this one away, to push this one away, to push this one away, and this one away, and so on. And what happens then that this one this continues on and continues to flow through the circuit, okay, as those electrons are moving in this particular direction. Now we know that an electric circuit needs to be a closed loop. It has to flow all the way back around, you know, so say on what you can see here, it needs to flow all the way back around and then to the positive side here. So what we actually have is that we've got a little bit of attraction that kind of goes on as well towards this positive electrode, positive end over here. So we're pushing away from the negative and we're pushing towards, or being attracted towards, the positive on the other end. And so what that's saying is that the size of this push force, okay, gives the amount of energy to the electrons. Okay, so that's shorthand for electrons, so E minus. Okay, so more push force equals more energy. We just said that the push force is also called voltage. So the voltage which is the word we use to describe how much of this pushing force is going on, is the amount of energy that's applied or given to the electrons in that circuit. So if I take this and if I say, all right, well, that's the size of the negative charge in this particular voltage, and let's say I ramp that up. I have a bigger voltage. Okay, so I have a bigger difference between a positive and a negative over here. And what that's going to do is that means that this will have more energy applied to it. It will push and push and push and push and push with more energy involved as it goes all the way through that circuit. So these electrons are carrying more and more energy as they move through. Likewise, if I took my original one and instead of turning it up, I turned it down. So I had only a little voltage. And then I go back to my scenario here. Then I only have a little push towards these electrons. Only a little push as it moves its way through. Okay, so there's less energy applied. Okay, so voltage in an electric circuit is the energy applied to the electrons. More voltage equals more energy applied, which also then means that there's more energy in these electrons to then be used. Okay, as that goes around the circuit, that voltage, okay, this energy that's applied here as it makes its way through, that gets lost or gets dissipated in all sorts of different places, and then it comes back, and then the energy that's involved is then pushing electrons around again. Okay, so each time it kind of comes back, it's like a pump that then pushes these electrons out with a certain amount of energy. All right, thanks very much for watching. Bye for now.